Guys, today we're going to analyze a special property, interesting property, I would say, of the three-digit numbers in math. Okay, let's say I have a three-digit number like 741. I reverse this number, 147, and I subtract these numbers. So I have to borrow from 4. So 11 minus 7 is equal to 4. Then become this 3. I have to borrow one more time. This becomes 6. This is now is 13. 13 minus 4 is 9. 6 minus 1 is 5. And then I'm going to add the inverse or the reverse of this number. So that will be 4, 9, 5. 5 plus 4 is 9. 9 plus 9 is 18. 1. So this is 6 plus 4 is 10, 10 89. Let's try a different number. Let's try um, a 1, 4. So the inverse of that is 418. We reverse again one more time. I have to borrow. 14 minus 8 is 6. This becomes 0, right? Sorry. Then I have to borrow one more time. This is 7. This is 10, right? Minus 1 is 9. 7 minus 4 is 3. I reverse this number. Add these numbers. 6 plus 3 is 9. 9 plus 9 is 18. Then you want 1, 7. So it's going to be 10, 19. So is that going to apply for all the numbers? How are we going to know? I'm going to use all the three-digit numbers, which is possible because it's a combination of 9 and 9 and 9. So it's a huge number of numbers, okay? But I'm not going to do that. We're going to use algebra. We're going to use that genetic numbers, which is variables, okay? So we're going to use algebra to prove this property, okay? So let's continue. So let's say instead of putting numbers, we're going to put A, B, C. The inverse would be C, B, A. All right. But I'm going to write this number in a different way. Remember, A is in the 100 place. So that will be 100 A. B is in the 10 place. So it will be 10B plus C. Right? C is in the 1 place. Minus C is in the 100 place. So that will be minus 100C minus 10B minus A. But I'm going to change the first statement. This one. I'm going to change it a little bit. I'm going to tweak it. Okay. So let me just put here. I need more space. 100. I'm going to put minus 1. Since I'm subtracting 100, I'm going to add back 100. Plus. Then I'm going to do the same thing with 10 with B. So it's going to be 10 B minus 1. All right. And I have to add back 10. And finally plus C. Over or minus 100C. All right. Minus 10B. And copying the second line. Okay. This one. The minus A. And then I'm going to do the math here. Right. So I'm going to put together all these two. So that will be 100. That will be A minus C minus 1. Right. And then they have 100 minus 10. Right. This one and this one. Minus 10 will be a 90. But instead of putting 90, I'm going to put 9 times 10. All right. So I'm done. Plus 10b and minus 10b, they cancel out. And I'm here. I'm left with C minus A plus 10. All right. So this is going to look like the number that you get after you subtracting this original ABC minus CBA. All right. So that means I had to reverse it to add it back, right? So add the reverse of that one. That would mean c minus a minus 10. So we plus 100 c minus a plus 10. This is going to be the same. The middle always stays the same. Plus this one, which is a minus c minus 1. A minus c minus 1. Why do I have to put 100? Because now it's in the one place. Why I put 100 here is because c minus a plus 10 is now in the 100 place. That I have to multiply by 100. All right, that's the reason, I multiply by 100 this one, and I eliminate the 100 for this one. All right, let's continue now. So let's calculate all this. I mean, you can do it, step by step, but this is not the purpose of the proof. It's just so c minus c, 0, a minus a, 0, a minus 1 is 9, 9 plus 100 is 900. Then this is 90, right? This is 90. 90 plus 90 is 180 plus a, minus a, right? Cancel out c minus c, 10 minus 1 is 9. The sum of all this is 1089. All right, easy. Okay, so that means based on this proof, no matter what number you have, what three-digit number you have in front of you, the answer is going to be the same. Subtracting the inverse and then adding back the inverse is always going to give you 1189. I hope you enjoyed this video.